Every framework you use, Spring, Django, Rails, has a factory method at its core. It is how frameworks let you decide which objects get created. If you understand factory method, you understand how frameworks work internally. Factory method pattern. Low-level design. Day 7. Here is the problem. You have a function that sends notifications. Inside it there is a switch case. If the type is email, create an email sender and call send. If the type is SMS, create an SMS sender and call send. If the type is push, create a push sender and call send. Now the product team says add WhatsApp notifications, so you add another case, then Telegram, then Discord. Every new notification type means modifying this function. This violates open-close principle. You are modifying existing code for every new type. The client code knows about every concrete class. It directly imports and creates email sender, SMS sender, push sender. This makes testing painful because you cannot swap implementations. The factory method pattern solves this with 3 parts. First, the creator. This is an abstract class or interface that declares the factory method. The factory method returns a product interface. Second, the product interface. This defines what all created objects must be able to do. In our case, a notifier interface with a send method. Third, concrete creators. Each creator overrides the factory method to return a specific product. Email creator returns an email notifier. SMS creator returns an SMS notifier. Push creator returns a push notifier. The key insight is that the client code works with the creator and product interfaces. It never knows which concrete class it is using. The factory method is the single point where object creation happens, and subclasses control what gets created. Here is the code in Go. First, define the notifier interface with a send method that takes a message string and returns an error. Then implement it. Email notifier sends via SMTP, SMS notifier sends via Twilio. Each struct implements the notifier interface. Now the factory function. New notifier takes a type string and returns the notifier interface. Inside a switch case creates the right concrete type. But here is the critical difference from before. The client code only sees the notifier interface. It calls notifier equals new notifier of email, then notifier.send of hello. The client never imports email notifier or SMS notifier directly. Adding a new notification type means one new struct that implements notifier and one new case in the factory. 0 changes to any client code. In Go, we typically use factory functions rather than class hierarchies. Factory method is everywhere in production code. First, database drivers. When you call SQL.open with Postgres and a connection string, Go returns a database/SQL.db interface. The Postgres driver decides which concrete connection to create. You write code against the DB interface, not the Postgres implementation. Second, HTTP handlers. HTTP.newRequest creates request objects. The framework decides the concrete transport layer. You work with the request interface. Third, logger libraries. Log.new returns a logger interface. You can swap between file output, console output, or remote logging without changing any application code. Fourth, payment gateways. New payment processor of Stripe returns a processor interface. Tomorrow you can switch to Razorpay by changing one line. All client code stays the same because it depends on the processor interface, not on Stripe directly. People confuse factory method with abstract factory and builder. Here is the difference. Factory method versus abstract factory. Factory method creates one product. A single method returns one interface. Subclasses override what gets created. Abstract factory creates families of related products. A UI factory might create a button, a checkbox, and an input that all match a theme. Multiple factorial methods grouped together. Factory method is about one product type. Abstract factory is about product families. Factory method versus builder. Factory method creates an object in one step. It returns a complete object and hides which class is created. Builder creates an object step by step. You call setName, then setAge, then build. Same class, different configurations. Factory method answers which class to create. Builder answers how to configure a complex object. When to use factory method. When the object type is decided at runtime based on configuration or input. When client code should not know the concrete class it uses. When you want to extend the system with new types without modifying existing code. When a framework needs to let users define their own object creation. Red flags that scream use factory method. A switch case or if-else chain that creates different objects based on a type parameter. Client code that directly imports and creates multiple concrete classes. Adding a new type requires modifying existing functions. Common interview questions. Design a document parser. Answer with a parser factory that creates PDF, Word, or Excel parsers via a parser interface. Design a payment system. Answer with a payment factory that returns Stripe, PayPal, or Razorpay processors via a processor interface. Design a notification system. Answer with a notifier factory that creates email, SMS, or push notifiers via a notifier interface. The pro tip is to show the switch case version first, then refactor to factory method to demonstrate you understand why coupling to concrete classes is bad. 5 things to remember. Factory method defines an interface for creating objects, but lets subclasses or factory functions decide which concrete class to instantiate. A switch case that creates different objects based on type is a code smell. Refactor to factory method. The client always depends on the interface, never on concrete classes. This is the key to extensibility. Factory method creates one product. Abstract factory creates product families. Builder handles step-by-step construction of the same class. And in interviews, show the tightly coupled switch case version first, then refactor with factory method to demonstrate you understand decoupling.